Okay, so today we're going to talk about enzyme kinetics, and before we do that, before we talk about any enzyme kinetics whatsoever, I want you to imagine a construction yard, all right? And on that construction yard, there are going to be construction workers, and their job is to convert some pallets of brick into building. All right? And during that time, right, the workers are going to pick up a pallet of bricks, and then they're going to work on them, convert them into building. All right. So the workers, are they going to it's their job to pick up these bricks. Are they going to want to pick up these bricks if it's their job?
Yeah.
Yeah, sure, right? And is there like some maximum speed at which like my workers are going to be able to build this building?
Essentially.
Yeah, basically, right? So if I have like 10 workers, there might be like some speed. If I have 20 workers, is that speed going to be greater?
Yeah.
Yeah, for sure, right? So we're going to have some sort of affinity for the bricks, right? And then we're going to have some sort of speed at which the building gets built. And that speed is going to be dependent on the number of workers I have, right? So in this example, let's say I have 10 workers, all right? Now I want you to consider three different, that's like the way that it should work, right? We have pallets of bricks, the workers are going to get the bricks, and then they're going to make the building. I want you to consider three different scenarios which this might not be working the same way, right? So the first scenario would be if a bus full of puppies breaks down in front of our construction yard. So if a bus full of puppies breaks down in front of our construction yard, then what's going to happen to our workers' attention?
They're going to be focused on the cute pups.
Yeah, right? There's like puppies there, and there's going to be like bricks there. Now, let's say I'm the foreman of the construction yard. I want my workers to get back to work. So let's say instead of 10 pallets of bricks, like, are they going to be paying attention to the bricks or the puppies if there's just 10 pallets of bricks?
Puppies.
They're going to be paying attention to the puppies. What about 40 pallets of bricks?
Probably still the puppies.
Maybe still the puppies, but you think they might start looking at the bricks a little bit?
Yeah, they might want to get out behind.
A little bit, right? What if I bring like 100 pallets of bricks?
Definitely bricks.
Definitely, right? And then like 400, 500, then they're all of a sudden they're not going to be focused on the puppies at all anymore. Eventually they get back to the bricks into the building if I bring enough pallets of bricks for them to work on. That makes enough sense, right? So I can fix this puppy problem if I bring them enough pallets of bricks. Let's consider a second scenario. We fix the bus, the puppies are back on the bus, they're gone. All right? In the second scenario, we have another like rival union, and this union has mob ties. And what the mob is doing is whacking some of our workers. So instead of 10 workers that show up to work, the next day I only have 5 workers that show up to work, all right? In this mafia example, right, let's say these workers don't know each other. Well, is their affinity for picking up a pallet of bricks going to be any different when they show up at work?
No.
No. But is the overall speed at which I build this building going to change?
Yes.
Yeah, absolutely. All right. So that's what happens when we introduce the mafia. And then the third example I want you to consider is if I have a lounge here, all right? Let's say that the workers have to pick up these pallet of bricks, and when they pick up the pallet of bricks, they have to get in the service elevator, and inside that service elevator is an Xbox 360, a plasma TV, a refrigerator with a bunch of Mr. Pibb and Dr. Pepper, and like those like little like Lunchable pre-made like, you know, peanut butter and jelly sandwiches, you know what I'm talking about? Pretty great. So like, let's say we have a lounge, and the only way the workers can get inside this lounge is to pick up a pallet of bricks. What happens to their affinity for the bricks?
Stay the same.
Does it stay the same? I mean, if they pick up a pallet of bricks and they go
or
inside
it gets
this
more
lounge,
because they want to go to the lounge.
yeah, exactly. They get to go to the lounge if they pick up a pallet of bricks, right? But what happens to the speed at which the building gets made?
A lot slower.
Oh, it's a lot slower, right? So that's what happens. We actually increase our affinity for the pallet of bricks, but we decrease our speed. All right, so that's a little example I want you to consider as we go through our lecture. All right.
How was that?
So, no, it's good. It's good. Now let's pretend like we went through this. We've gone through the lecture. So in today's lecture, we talked about enzyme kinetics. It's still recording. So, we've gone through enzyme kinetics, and we talked about Km. So Km is enzyme affinity, right? So as the enzyme has a larger affinity for the substrate, what happens to Km? Increase or decrease?
Increase.
Decrease, right?
Wait.
as I increase the affinity for for the substrate, what happened to the Km? Increase or decrease?
Decrease.
Yeah. So Km has an inverse relationship with affinity. And then we have Vmax, which is like the maximum speed at which our enzyme can work. And then we have competitive inhibition, we have non-competitive inhibition, and we have uncompetitive inhibition. All right, we talked about each of those as well. All right, so in this example, right, where we're talking about the pallets, the workers with the bricks, and the building, our affinity is Km, right? And our ultimate speed is Vmax. And the workers plus the bricks is like our enzyme substrate complex, okay? So remember our first situation when we had the bus full of puppies, or let's say like it's a bus full of like puppies and models that breaks down in front of our construction yard, then what happened to the workers' affinity for the pallet of bricks? Did it increase or decrease, stay the same?
Decrease.
Yeah, so we decreased our affinity for the pallet of bricks. What does that do to the Km?
Increases.
It increases our Km, right? So when we have the puppies, which counts as competitive inhibition, right? Then we increase our Km. Did our overall work change? Did our speed of work change? No. There's no change to the Vmax. Okay. What about the mafia? The mafia would be like if we had non-competitive inhibition, right? The mafia doesn't even want to compete, right? So we have non-competitive inhibition. So when the mafia is whacking our workers off one by one, did the workers' affinity for the bricks change?
No.
No, right? They still come to work, ready to work. No change in the Km. All right? No change in the Km. When the mafia is whacking our workers, though, what happened to the eventual speed at which the building gets made?
Decreased.
Yeah, we decrease our Vmax. Okay. And now, when we have this lounge, remember, it's like when we have that pallet of bricks, the workers pick up the pallet of bricks, they get into the service elevator, and all of a sudden they want to spend all their time in the service elevator. They want to spend all their time as the enzyme substrate complex, because that's what happens when an uncompetitive inhibitor binds. It binds the enzyme substrate complex. So what happened to our affinity when we introduced that lounge?
Increased.
It increased our affinity, right? Okay. What happened to the Km then?
Decrease.
It decreases the Km. Fantastic. This is uncompetitive inhibition. When we have a lounge, we decrease our Km, and then what happens to the ultimate speed at which this gets made, the building gets made?
It decreases.
It also goes down. This is also a decrease in Vmax. All right? And frankly, if we introduce a lounge into our construction company, that makes it a really uncompetitive company anyway, right?
Right.
And that's the reflect portion.